Hi, Nutrition 101. This is section 1 and 2 of chapter 4, carbohydrates. So we're going to start out this chapter by talking a little bit about whole grains versus refined grain. A whole grain contains three parts: the endosperm, the bran, and the germ. The endosperm is the largest part of the kernel. It's made up of primarily starch, also contains some protein, and a few vitamins and minerals. The endosperm is pretty much what we think of as being the starchy part of a grain. So when you consume white bread, when you consume a potato, any of those things that we think of as being high in carbs are typically high in starch. The outermost layer is the bran layer, and that contains most of the fiber and is a good source of lots of vitamins and minerals. If you think about something that has bran in the title, like all bran or wheat bran, you can think of a coarse, hard, insoluble sort of fiber that has a lot of health benefits, especially for the colon. The germ is located at the base of the kernel, and that's where the sprouting occurs. It's a really rich source of oil and is rich in vitamin E, and wheat germ is actually used to sprinkle on top of yogurt or cereal or things like that as a nutritional supplement. So when we look at what whole wheat flour has going for it versus refined flour or polished grains as they used to call them, the polished grains or refined flour removes the bran and the germ and is only left with the endosperm. Therefore, you can see that little line at 100% whole wheat flour. You can see that's how much of each nutrient is available, and you can see that only maybe 10 to 20% of those same nutrients are available in the refined flour because most of those vitamins and minerals are found in the bran and the germ. We enrich all grain products, which means we add things back that were taken out during processing. So we add back 3 B vitamins, thiamine, riboflavin, and niacin, to pretty close to where they were originally in the whole grain. And we also add back iron, which is a mineral. You can see that folate, which is actually added back as folic acid because food folate is not available in supplemental form. It's a different compound called folic acid. That is added way above and beyond, and that was added in the early 2000s as a public health concern to help to prevent spina bifida in infants. Folate's important for neural tube development in the first month of pregnancy. It was found that a lot of pregnant women weren't consuming enough folate in that first month of pregnancy, and a lot of women are consuming refined flour. So folate started being added back to that refined flour in order to prevent that public health concern, and spina bifida incidence went down. So when we look at refined carbohydrates, and that could be refined flour, that could be refined sugar, when we look at refined carbohydrates, we care because, as you can see here, in terms of a kiwi versus some soda, even if we look at the same number of calories, which is often what people look at first, right? How many calories does this have in it? The nutrient density of the calories of, say, a kiwi is so much higher than that of soda. So you can see the calories and the macronutrient, carbohydrates, are the same, but the vitamin C, the folate, and the calcium are much higher in that kiwi than the soda. And you can see that same thing in the enriched flour, right? So you look at the refined flour versus the whole grain. There's just so much more going for that whole grain if you're looking at calorie for calorie. So let's move into our chemical carbohydrate types. So if we look at carbohydrate types, there are really two classes of carbohydrates: simple sugars and complex carbs. And under the simple sugar category are two different subcategories. The first one is monosaccharides, and the second one is disaccharides. Now, monosaccharides all have the same chemical formula, C6H12O6. However, they're just structured a little bit different. So you can see fructose has a little 5-point ring, whereas galactose and glucose have 6-point rings. So you can see they're just structured slightly differently. That gives them different chemical properties and also different flavors. Glucose is the monosaccharide that circulates in the blood, and it's also the base of all other more complicated carbohydrates. Galactose is rarely found alone. It's a monosaccharide, and it's part of what makes up lactose, which is milk sugar. Whoop. Fructose is a monosaccharide that's found in fruits and vegetables. It makes up more than half the sugar in honey and in high fructose corn syrup. It's used to sweeten a lot of beverages because it's quite sweet when we extract it. It's also cheap. Something like high fructose corn syrup is pretty cheap to produce. So now we have our disaccharides. So if you add a glucose to any monosaccharide, you make a disaccharide. So there are three of those. Glucose plus glucose equals maltose. So maltose is usually the byproduct of starch digestion. So if you left a piece of bread or an unsalted cracker in your mouth for a long period of time, you would start to taste a sweet taste. That's maltose. That salivary amylase in your mouth is starting to digest the starch and breaking it into smaller chains. Maltose is also found in malt liquor as well as malt balls, which brand name would be Whoppers in the U.S., or Ovaltine, that powdered chocolate milk that's high in vitamins and minerals, or malted milkshake. So it almost has like a chalky type taste. Sucrose is glucose plus fructose, and that's our table sugar. So it's the only sweetener that you can call sugar on the ingredient list on food labels in the US. Sucrose is a byproduct of sugarcane, right, that's spun around many times, and you end up with this cane sugar or sucrose on one side, and then you end up with molasses on the other side that's typically used for cattle feed. Lactose is made of glucose linked to galactose, and that's often called milk sugar. So that's naturally occurring in milk. You'll always see a few grams of natural sugar in milk. Now you can see the linkage looks a little bit different. So the linkage on galactose plus glucose requires an enzyme called lactase to break it apart. Lactase tends to be intolerable or not present in many people's guts, and so they cannot digest lactose well, which is called lactose intolerance. Now we have our complex carbohydrates, which include three: glycogen, starch, and fiber. Glycogen, first off, is the polysaccharide that's made of branch chains of glucose. We store some glycogen in our body. In our liver, we store about 400 calories of glycogen, and in our muscles, we store about 1,600 calories of glycogen. The glycogens found in muscle and liver, as I mentioned, can be broken down really quickly when the body needs glucose. So the muscle glycogen is used right away in the muscle as the muscles need to contract to use that energy, and then the liver glycogen is broken down to release into the blood to raise blood glucose once blood glucose is low after an insulin response, a couple hours after a meal. Starches are typically found in our starchy vegetables like potato and squash and carrots. I always say all the Thanksgiving vegetables, and also in grains. And then fiber is found in our whole grains and fruits and vegetables. Some fibers are insoluble, so those are usually what we think of as roughage, like broccoli, corn, leafy greens, wheat. And then we have our soluble fiber, which is more viscous. So that would be like the fruit pectin, jam, jelly, could also be something like oatmeal. And so just as a review, here are our simple versus our complex carbohydrates. You can see that monosaccharides are galactose, glucose, and fructose. Disaccharides equal galactose plus glucose, which is lactose, glucose plus glucose, which is maltose, or fructose plus glucose, which is sucrose. Then many chains of glucose are starch, which is our plant storage form of energy. Many molecules of glucose in branch chain formation is glycogen, which is our animal storage of energy. And many chains of glucose in a combination linked together that we can't digest or can't break those links is fiber, which includes soluble and insoluble. Our polysaccharides are also another name for complex carbohydrates, and then disaccharides and monosaccharides are another name for simple carbohydrates. Next time, we're going to be talking about digestion and absorption and metabolism of carbohydrates. Now, we break down all carbohydrates for absorption, which can only be galactose, glucose, and fructose. So we can only absorb galactose, glucose, and fructose. So the purpose of digestion is to take anything more complicated than that, break it down into the monosaccharide form, and then absorb or take it into the body. So something like fiber, for example, is actually never digested or absorbed, so all of its functions occur right in that GI tract, which then can result in, other health consequences over time, such as lowering cholesterol, decreasing the risk of colon cancer and things like that, but all of its functions just reside in the GI tract. So stay tuned for next time. We'll talk about digestion, absorption, and metabolism, and make sure you study up on all of these terms for mono, di, and polysaccharides, as well as the different parts of the grain, refined carbohydrates, um, whole grains, simple sugars, empty calories, nutrient density, all of those vocabulary words that we just keep bringing back over and over again to prep for our next lecture. Thanks a lot. See you next time.